Calculus 7.4, Day 1, Exponential Growth and Decay. It's going to start off pretty simple today. We're just going to solve a few differential equations, but things will be a tiny bit different because we will have differential equations in terms of y as well as in terms of x. So let's get started. Polyjuice potion is a potion that allows a drinker to assume the form of someone else. It is a highly complicated, challenging, and time-consuming potion that even adult witches and wizards struggle to brew correctly. The potion is incredibly advanced and has two separate parts that contain steps for each part. When brewing is complete, the potion has to stew for a month before usage. Now that's more about Polyjuice than I probably ever wanted to know. Now earlier in the chapter, I think it was back in chapter 6 even, we talked about separable differential equations, and they are differential equations that you can separate the y's onto the left side and the x's on the right side. Naturally, it doesn't have to be y and x. It could be, theta and t, but whatever. You just want to make sure that you can, through division and multiplication, get all of the independent variables on the right side and all the dependent variables on the right side. So we've done easy ones so far. We're going to take a look now at some that are a tiny bit more advanced. Here we're going to solve for y. dy dx equals y squared x squared, where y is 1 when x is 1. Remember, the y is 1 when x is 1. That part is our initial condition. And in this case, we don't just have an x, we have an x and a y. So we get to practice separating variables. To guide you through here, we are multiplying both sides of this differential equation by dx over y and over y squared. And when I do that, over here on the left side, those dx's are going to cancel out. On the right side, we can see that the y squares are going to cancel out. And that leaves us with, on the left side, 1 over y squared multiplied by dy. And on the right side, we get x squared dx. On the next page, we need to actually integrate. There is a note here that says the plus c only needs to be on the right side, and we had a pretty in-depth discussion about that, I believe, in 6.2, maybe 6.3. So let's see what happens here. The antiderivative of y to the negative 2 power, that's just negative 1 over y. And now on the right side, we have to find the antiderivative of x squared dx, and that's just 1/3 x cubed. Now at this point, we can either solve for the initial condition or we can solve for y. There are two different paths that people take: solve for the initial condition or solve for the variable. For this problem in particular, we're going to solve for the initial condition first. So if I substitute 1, 1, which was the initial condition, I get negative 1 equals 1/3 plus c. So c has to be negative 4/3. Now as a last step, we're going to have to solve for y. Now this is necessary because we are being asked to solve an initial value problem, and so if our answer is not in the form of y equals an equation, we didn't really do it. So here's what we're going to do. On the right side, we're going to put everything to a common denominator, and that's not that big a deal because this first term, 1/3 x cubed, can be rewritten as x cubed over 3, and then we already have minus 4/3, so that's just going to look like x cubed minus 4 over 3. The next step is to multiply both sides by negative 1. Notice the effect on the numerator. This is an effect that a lot of students don't see right away. But if you multiply x cubed minus 4, if you multiply that by negative 1, you get 4 minus x cubed. So that's like a simplification and a multiplying by negative 1 all at the same time. Of course, the denominator is still 3. Taking a look at that whole equation, we got 1 over y equals 4x cubed over 3. And so what we're going to do is we're going to take a reciprocal of the entire left side and a reciprocal of the entire right side. Now be careful when you're doing this. You need to make sure that if you're going to find the reciprocals, that you have one fraction on the left and another fraction on the right. If it doesn't look like that, fraction equals fraction, then you're probably going to do this wrong. And that is a particular solution if I ever saw one. We've got y equals an equation in terms of x and in terms of x only. And we started off with a differential equation which was none too obvious. dy dx equals y squared x squared. So that's where all of that leads. And that is really the major tweak that we're doing here today, where we have to integrate both the left side and the right side, and then through algebra solve for y. Now here's another example of the same thing. We're going to solve the differential equation dy dx equals x over y squared. Same initial condition, 1, 1. Same setup. We start with our differential equation. We'll multiply both sides by y squared dx. Cancel the dx's on the left. Cancel the y squareds on the right. That simplifies into y squared dy equals x dx. We have successfully separated our variables. Integrate both sides. Now this left and the right side here, those aren't too difficult to find antiderivatives for. I notice that on the left side I have a 1/3, and I try not to keep any constants on the side with the dependent variable, so I'm going to multiply both sides by 3. But wait a minute, isn't 3c just a constant? And if it's just a constant, do I really need 3 times c? The answer is I don't need 3. So most of the time when we have a constant multiplied by another constant, we just simplify it to c. Okay, I think my last step here is a cube root. So here's our general solution. What I want you to notice here is the position of the constant. We've been very used to general solutions that have a plus constant as its own separate term at the very end. And starting with today's lesson, we're going to find that the constant is not necessarily just plus c at the end of some long equation. That plus c, the constant, is actually an integral part of the equation here, and it's inside the cube root. So be aware of that. For those of you who like to just jam a plus c at the end of every antiderivative, you're not going to be able to do that and get great results. Simplifying or solving for that c, we're going to substitute our initial condition 1, 1. We get c is equal to -1/2. So y is the cube root of 3/2 x squared minus 1/2. That probably looks nicer as cube root of 3x squared minus 1, the whole thing over 2. So here we are. This is our differential equation, and yeah, this was more advanced than what we were doing, but it's just more advanced in that we have to integrate on the left and the right. The solving for y tends to be actually the most difficult part of this, because you're going to have to practice your algebra here to do that. Let's see what other goodies we can get up to. Oh, look, that's it. We're already at important ideas. We already know what we need to do for this. So to solve differential equations, we can actually kind of break it up into 5 steps. Usually 3 is enough if we're just doing a general solution. So we need to separate the variables, of course. And then after that, we're going to integrate. Make sure we put the plus c only on the right side. And then we solve for our dependent variable to create that general solution. Now, if necessary, you're going to have to substitute that initial condition to get a particular solution. And of course, make substitutions to solve the problem. Substitute the initial condition. It seems kind of redundant there. Sometimes you will have to make corrections to your general solution because of the domain of a function. For example, you need to make sure that inside of your square roots, you're always substituting a positive value. But we'll definitely get more into that in the future. So here is our check your understanding. Polyjuice potion takes a month to cure. Curing, of course, is finishing that brewing process. And so suppose that PT is a percent of the potion that is cured, and the differential equation dp dt gives the rate at which the potion is being cured. We've got dp dt equals 32 over 3 cube root of t squared. And the question here is how many days until the Polyjuice potion is 50% cured? So when is p equal to 50? Hint, we have this initial condition at t equals 0, the potion is 0% cured. First step here is to separate variables, and I'm going to immediately write this as 32/3 t to the negative 2/3 power, because this is how we're going to integrate this. Separating variables here is really just multiplying dt. This isn't that advanced of a differential equation in that we don't have any p variables on the differential equation. Okay, we have integrated, we're going to integrate both sides. The left side dp, that antiderivative is just p. And on the right side, we can do a little bit of calculations ahead of time. Let's see, 2/3, negative 2/3 plus 1 is 1/3. So this is going to be t to the 1/3 power. The reciprocal of 1/3 is 3. So I have to multiply both sides by 3. Not both sides, just the t. So we've got 32/3, 3t to the 1/3 plus constant. That gives me 32 cube root of t plus constant. Now for the second part of this, we know that p of 0 is equal to 0, so we can get a value for c. So p0 is 32 cube root of 0 plus c, and that's equal to 0. Therefore, c is equal to 0. And I get myself a particular solution of p equals 32 cube root of t. Now for the last part here, we want to solve for t when p is equal to 50. In other words, we want to solve pt equals 32 cube root of t equals 50. Let's solve this algebraically first. And that's not that big of a deal. We got t equals the cube of 50 over 32. Of course, if you do get a calculator, I kind of recommend you just use the solver. There's no reason to do any algebra or solve anything algebraically if you have a calculator in front of you. I highly recommend against it. And all we need is a guess for t, and you know, any guess will probably work. Let's put a 15 here. Alpha enter. And I get 3.81469. And just to check here, if I calculate the cube of 50 over 32, that should give me this. Yeah, that gives me 3.814. So, looking pretty good. The Polyjuice potion is 50% cured after 3.81469 days. So this is a pretty good introduction. It's a nice break right after your... oh no, this isn't after the test anymore. So yeah, have a good one. Enjoy. And don't forget to solve for y. See you next time.